it is never a good practice to use the same pit used for your thunder arrestor to harden your thunder arrestor, also to harden your electrical installation of the building. They are two different things. I think he said it. Though both are earthing, the essence of earthing in electrical installation is to create a low resistance path for the fault current to flow away. Anytime there is leakage between the live and the earth, that leakage, because of the severity of that leakage, if anybody touches it, it's going to feel the severity. So that is why you earthing all the metal framework in that installation. By connecting all the metal framework of all the appliances, sockets, distribution board, and you ground it, so you have provided a low resistance part. Grounding it, you remember we still had charcoal, industrial salt, animal dung, and so on. The essence of those things is to reduce the resistance of the earth. When current is flowing away, fault current, and it wants to enter the ground also has its own resistance. Are you getting me now? And current does not flow through a high resistance part. That is why you had industrial salt. That's why you had charcoal. All those components help to reduce the conductivity, increase the conductivity of your ground, of your soil, so that when current is flowing, current can easily flow away. And in electrical engineering, we believe there is what we call earth fault loop. Earth fault loop. Anytime there is a fault in an installation, you create a path for that current to flow away and back to the supply transformer. Are you getting me now? Yes, you know, when they want to install a transformer, they normally ground it, and the earthing is very, very effective, very active. So it is to create a low resistance path, because the supply transformer remains the source from which all other residencies
are being connected.
Connect the supply from. So if the fault comes from your own, it has to return to that path, because there must be a complete path for that fault loop. You want to harden your thunder arrestor, you are protecting the building. It also depends on location. If your house is bungalow, but it is positioned in a very hilly place, I don't know whether you experience that. There are some houses, time to time they keep calling you that there is thunder strike. It is because it is positioned on the path of the thunder, because of its location. So in that case, you are going to protect that building. Structure of that building is where you attach the thunder arrestor to and ground it. And the voltage that is coming through your thunder arrestor anytime thunder strikes is of several thousands. It's of several thousand that is capable of destroying anything that stands on its way.
That is below
so it is wrong for you now to use the same earth speed to ground the structure and your distribution board, that is your electrical installation, because whenever that voltage is also voltage,
high
not in that order, but high voltage. Even at times when you leave your charger on the socket, you see your charger will glow. It will glow light, telling you that there is induction. Voltage is coming through a particular path, and if it travels in the right direction of the thunder arrestor being a conductor will conduct that high voltage, send it through the copper tape down to the ground. But if you now pick your earthing for your electrical installation from the same pit, which means as that high voltage is grounded, it will flow back to your installation.
Destroy.
So it's like you have created another path for that fault current to flow back into your installation. Try to create distance between them before you harden them. Even you can choose different location.